Continuing on with example 2 here. Now, what is the sum of the two rational expressions in simplest form? State any restrictions on the variable. Again, our first step is always to get common denominators. And to find our least common denominator, we find the least common multiple of our denominators. And to do that, we factor. Here, I'm going to factor out what's common. With x squared minus x, I have a common x. And what I have left is x minus 1. And I get that by dividing. So if I divide out an x, and I divide out an x, I'm left with x times x minus 1. A lot of you guys are going to forget that minus 1. Don't. We still have to have that factor. If we start with a binomial, we should end with a binomial. If we start with a trinomial, we should end with a trinomial when we factor out just the common factor. Now, to find our least common denominator, we find our least common multiple of our denominators. So, I have x minus 1 from my first fraction. In my second fraction, I have x minus 1 times x. So, my LCD is going to be an x times an x minus 1. Here again, we can also check for restrictions on our variable. So, x cannot be 0. X minus 1 cannot be 0. Again, remember the restrictions on our domain are any time that our denominator is 0. We can never divide by 0. So, x cannot be 0. If we add 1 here, x can also not be 1. It's a restriction on our variable. Now that I have my common denominator, I want to get both my denominators to be the same. So I'm looking for x times x minus 1, which in my second fraction I already have. In my first fraction I'm missing an x. So I'm going to go ahead and multiply by x in my denominator to get that common denominator. Then again, remember, whatever I do to my denominator, I have to do to my numerator to keep it equivalent. If I divide by a number, I also have to multiply to keep it the same, because x divided by x is just 1. 1 times anything is itself. So I didn't really change the value there. I just made it equivalent denominators so that we can combine them. Now that I have my common denominators, I'm going to simplify my numerator. X squared plus x when I distribute there. I have negative 2 over x times x minus 1. I can put these together since I have a common denominator, add up my numerator, and just place it over my common denominator. Again, we want it in simplest form, so go ahead and factor your numerator. If it does, it's not always going to factor, guys, and that's okay, but always check and see if it does. We want to multiply to 2, subtract to 1, which is 2 and 1. Different signs. 2 is bigger, it gets the sign of the middle term here. Last step, anything divided by itself is 1. So my final answer is going to be x plus 2 over x, as long as x is not 0 or 1. Try B here. Again, our first step is to get our least common denominator. And we do that by finding our least common multiple of our denominators. First we factor. Have to have our prime factors before we can find our least common multiple. And x squared minus 4 again is a difference of squares, which means I need to multiply to 4, subtract to 0, plus and minus 2. My least common denominator here, I'm going to make my columns. For my first fraction, I have x plus 2, x minus 2. In my second one, I just have x plus 2. So my least common denominator, things that I have common between these, I have one x plus 2 factor, one x minus 2 factor. This is my LCD. While I'm over here, I'm going to find my restrictions on my domain. X plus 2 cannot equal 0. So x cannot equal negative 2. X minus 2 cannot equal 0. So x cannot equal positive 2. So my domain restrictions are x cannot equal plus or minus 2. Now that I have my common denominator here, I use it to create equivalent fractions. My first denominator, I already have the x minus 2. I already have the x minus 1. My second denominator, I already have the x minus 2, but I'm missing this x. Sorry, I have the x plus 2, but I'm missing the x minus 2. So I need to multiply by x minus 2 to get that common denominator. And whatever I do to the denominator, I have to do to the numerator. Okay, now 1 times anything is just itself. So all I have here is x minus 2. I can go ahead and add, since I have a common denominator, add my numerators, place it over that common denominator of x plus 2, x minus 2. I have x plus x minus 2. X plus x minus 2. Simplify here, I get 2x minus 2 over x plus 2, x minus 2. The only thing I can simplify there is I can factor out that common 2 from both of my terms in my numerator. I'm left with an x and a minus, and do not forget that 1 there. Remember, when we factor out, it's like we divide. Let's divide both of those. 2 divided by 2 is 1. 2x divided by 2, 2x divided by 2 is x. So I have 2 outside times x minus 1 over my least common denominator, x plus 2, x minus 2. And my domain restriction is right there. One thing to note here, guys, sometimes the book writes your denominator in multiplied form. So instead of having it in factored form, they have it in more of a standard form. That's okay. So you could either have x plus 2 times x minus 2, or you could have FOILed that together and got an x squared minus 4. Either way, it would work for me. So whether you have this or this, I don't have a preference. Example 3 is subtracting rational expressions. What is the difference of the two rational expressions in simplest form? State any restrictions on the variable. Guys, this is very, very similar to what we did with addition. So, first step again is finding our least common denominator by finding our least common multiple. In order to do that, we need to factor. Take out the common x, and I'm left with x minus 2. Here, I have a common 2. When I take out my 2, I have an x minus 2. So when I list these out, I'm going to make a column for my x's, a column for my x minus 2. I'm going to make a column for 2's, and I'm going to put my x minus 2 in my x minus 2 column, which I already have. So my least common multiple is going to be 1, 2 times 1x times 1x minus 2 factor. And that's going to be my least common denominator. Again, we're going to check for any restrictions on our domain the exact same way we did before. 2x can't be 0. X minus 2 cannot be 0. Divide by 2. X can't be 0. Add 2. X can't be 2. Restrictions. Okay. X cannot be 0. X cannot be 2 because I added 2 here. Now that I have my least common denominator, I'm going to try and get both of these to be the same. So right now, I look at my least common denominator. In my first one, do I have the 2? No, I need it. Do I have the x? Yep. Do I have the x minus 2? Yep. In my second one, do I have the 2? Yep. Do I have the x? Nope, I need it. Do I have the x minus 2? Yep. Now, whatever I multiplied my denominator by, I have to also multiply my numerator by. So since I multiplied by this x here in my denominator, I have to do it in my numerator. Since I multiplied by this 2 here in my denominator, I also have to do it in my numerator. So I'm going to go ahead and distribute and simplify my numerators right now. And what I have is 2x plus 4 over 2x, x minus 2, minus, my second fraction is going to be x squared plus 2x over 2x, x minus 2. So far, absolutely nothing is different. Nothing is different between subtraction and addition. The only thing that's going to be different now, guys, is that we have to remember that this subtraction goes to this whole thing. This whole second term, that whole second rational expression. So we need to distribute it to both pieces. I have 2x plus 4 from here, minus x squared minus 2x. We subtract this whole numerator, and that's all over my common denominator. I'm telling you right now that this right here, you guys are going to forget to do. You're going to forget to take it to the second term. Don't. Okay, we're subtracting that whole thing. So we're taking 2x plus 4 minus x squared and minus 2x. We're subtracting the whole second numerator. Now combine your like terms. 2x minus 2x. I get negative x squared plus 4 over 2x, x minus 2. But I don't ever want to have my x negative. So I factor that out. And I have negative x squared minus 4. Again, I just divide to factor it out and account for it in the front, which changes it to a minus 4 over my common denominator. I'm going to rewrite that because it's a difference of squares, x minus 2, x plus 2, and all I did was simplify this. That's over my LCD. Now, anything divided by itself is 1. So right now, I'm going to be left with negative x plus 2 over 2x, as long as x is not equal to 0 or 2. And just like yesterday, guys, we can't always see from our final answer all of our restrictions, and that's why we have to check our domain right away with all of our denominators. So before we simplify anything out, while it's still in factored form and we can see them a little bit easier, that's where we check our restrictions. Okay, again, if you would have wanted to here, you also could have put negative x minus 2 over 2x. That would have worked as well. You could have distributed the negative if you wanted to. I don't have a preference. I'm going to end this video here and we'll start on the next one.